I've come up with your very next video from electrochemistry, and this time is going to be next to where I left. I need to remind you in case you need. The previous topic I did was, limiting molar conductivity and the Collard's law. And I hope you have understand that. And if it was really, worthy, whatever I tried to, in case it was, you just do let me know. But right now, the very next topic in that sequence is Faraday's laws of electrolysis. And the first thing I'm about to start is called what is electrolytic cell, right? You have studied so many cells earlier. There was galvanic cell, Daniel cell, then even I had a conductivity cell. Now this time we are going to be talking about electrolytic cell, and then based on that we'll be coming to the Faraday's law, right? So let's write about and try to get it. So what is an electrolytic cell? Right? So an electrolytic cell, the cell in which an external potential is used to bring about a non-spontaneous process. So let me repeat back. What is an electrolytic cell? An electrolytic cell is a cell where a non-spontaneous reaction is carried out using external source of power. Because it is non-spontaneous, it has to be provided some external energy, and otherwise you call it spontaneous, where the reaction takes place on its own. So this is what electrolytic cell is. So what are the reference of this topic here? Suppose this is a container right here, and you have two electrodes being placed. You have two electrodes here. These two electrodes needs to be connected with a source of voltage. Right? So as you can see, this is your anode and this is your cathode. This is your cathode here. And this is your anode here. Now what you have to do, you have to put some electrolytic solution inside. Right? So there is an electrolyte solution. Electrolyte solution you have. So what you see that the cathode, what happened actually on the cathode when you let the current pass, what happened? First thing happens is that from the anode a certain amount of metal dissolve, and that very same amount of metal deposit on the cathode. So there, what is happening? Depositing, and what is happening here? Dissolving. So this undergo dissolving while this undergo depositing. So is there anything, I hope, one more thing, which if you mind that, which I don't. So this is what an electrolytic cell is, where to bring about a chemical reaction, you have to use a external potential here, right? And this external potential is used in order to carry out the whole reaction. So based on that, next thing I'm going to, let you know is Faraday's law. Is Faraday's law of electrolysis. There are basically two laws It's the first law. Let's talk about the first law here. Let me introduce you the whole thing back here. You know, every time there is some electrolysis taking place, you know, the amount of substance that is dissolving and amount of substance that is depositing, they follow a certain rule, and that rule is nothing but Faraday's rule, Faraday's law. The first law says that the amount of a substance dissolving from an electrode and amount of substance depositing on cathode is directly proportional to the amount of charge passing through the solution. Let me repeat back, because all these are interlinked here, and I hope you are concentrating, because I'm doing the same way. There is a beaker out here with two electrodes. The left one is connected to battery positive terminal, the right one is connected to battery negative terminal. So the one which is connected to negative is called cathode, and the other one which is connected to positive is called anode. Now once you start flowing the current, what happens? The anode start dissolving. While the cathode start getting depositing. So some amount of chemical is dissolving here and an equal amount of chemical is depositing on the cathode. So what are the rules that are being followed during the reaction? These rules are governed by Faraday's law. So Faraday's law simply says that amount of substance dissolving here and amount of substance depositing here, both of these or either of these are directly proportional to the amount of charge passing through the solution. So in short, we can write mass is directly proportional to charge. We can also write it like M equal to Q. We can also write it like M equal to Z into Q. What Z is? Z is called, constant called electrochemical constant, or this is just a constant. You can also call it equivalent chemical constant. So constant is here. Now we need to find out what Z is. So Z is equal to equivalent weight of a substance divided by charge in 1 mole of electron. If you try to expand it, equivalent weight, you do know that is equal to the molar mass divided by number of electrons required for reduction, and then there is again here divided by what is the charge of 1 mole of electron? The charge of 1 mole of electron is 6.022 into 10 to the power 23 into 1.6 into 10 to the power minus 19 coulomb. So I'm going to use that right over there. So can we write it like M is equal to, this is going to be like equivalent weight divided by 96500, because this is what the value is coming out to be. This will be coming out to be 96500. So there it is, right? And then multiplied by Q, right? Okay, let me expand it a little bit here also. So what we have M equal to that is equivalent weight of a substance divided by 96500 into Q, right? If you do know equivalent weight divided by 96500 into Q is also equal to I into T. So this is what finally the formula is coming out to be. So amount of substance dissolving is equal to equivalent weight into I into T. What I is the amount of current passing through, and T is the time for which the current is passing through. So there you need to concentrate, because this is what Faraday's first law relates to you. Let me repeat you so that there's so many things you understand quite easily. Faraday's law says that during the electrolysis, the amount of a substance dissolving or the amount of a substance liberating on the anode and depositing on the cathode, either of them are directly proportional to the charge passing through the solution. So therefore, we have mass is directly proportional to charge. Now we do know proportionality has a constant. So this constant is called Z. And Z is equal to, Z is here been described. Z is equal to equivalent weight of the substance, whatever, maybe zinc, maybe copper or whatever. So equivalent weight of the substance divided by, charge in 1 mole of electron. Now, if you remember from the previous video, which I hope you do, so equivalent weight is equal to molar mass upon number of electrons required for reduction of a species. So, and divided by charge in 1 mole of electron. So what is 1 mole of electron charge? The value of 1 mole is 6.022 in 10 power 23. And what is the charge of 1 mole? 1 electron, 1.6 into 10 power minus 19 coulomb. If you solve it, you are going to have this value 96500. So therefore, M is equal to equivalent weight upon 96500 into Q. Now, I did a little bit of expansion here. Q is also equal to I into T. I hope you do know. Q is also equal to I into T. So therefore, this equation comes out to be as the final part here. So this is what the Faraday's first law is. I don't know how long this video has come out to be, but I want to, do the Faraday's second law of electrolysis in the next part, right? That may be a short one, but I think I need to, make sure that this ends here. And if I'm going to end this, I must tell you, just take care, and if you are serious about what you are doing, definitely you need to be very, very serious, because your study and your perception of life and everything you feel about the people you care about is not some joke. You need to be really serious. And when you're serious, when you do something very positive, you definitely feel a kind of pleasure inside you, a kind of happiness, a kind of contentment you feel inside, a happiness inside you. So that is what what I feel is the bigger part of the life. So to have that, you need to be honest, you need to be very hardworking, and at the same time very, very affectionate you have to be. So that's it. Thanks for watching.